Good afternoon everyone and welcome to today's video. Today I'm going to be showing off my latest fixture design for our production here at Pro Technologies. If you haven't followed me on LinkedIn, I would invite you to. That is where I post most of my fixture updates and the current things I'm working on, and this being one of them. So if you've missed the design journey for this fixture, please, I would invite you to go follow me on LinkedIn and make sure you catch up on all that. But today I'm going to be showing off what exactly this fixture does. Now, this fixture's main job will be to communicate with this battery pack. This battery pack is an 8 series lithium iron phosphate battery pack, and we are cycling it in production before it goes to the customer. Now, in order to interface with the battery pack, make sure that no flags are thrown or nothing's wrong with the battery pack and the BMS isn't reporting anything bad, normally you would use a computer for this. You would plug it up and use whatever the relevant software, whether it be Texas Instruments or Maxim software or a couple of other vendors. You would use their software and look at the battery pack and make sure everything's good. However, that can be very tedious, very time consuming for production. So that's where this little fixture comes in. I took a small Arduino Nano and programmed some firmware into it and some different things and put LEDs on this fixture in order to interface with this battery pack, so that way production could get a green or a red light and they would know, hey, this battery pack needs to be evaluated, or this battery pack is good to go. We can put it on the testing system and then ship it out. So let's take a look at this fixture real quick and see exactly what it's all about. Now, let's walk through exactly what the fixture is about. Now, as you can see, if we're going from left to right, we have a power LED, we have a boot switch, a system present switch, a comms indicator, and a status indicator. The power switch obviously being just normal power. Whenever the Arduino boots up, the boot switch, the specific BMS on this battery pack must be booted when it first comes from the manufacturer. So thus the boot switch. System present, of course, is standard for any kind of BMS. That's your on and off switch for the output FETs of the battery pack. COM status is whether the device can communicate with the battery pack, and then your status indicator is whether it has passed your test or not. So I'll pull the battery pack around here and we'll demonstrate exactly what it does. I have the fixture and the battery pack set up as it would be in production. The fixture obviously would be ready to interface with the battery pack. So let's test it out and see how it works. Turning on the power switch just has its normal startup condition. You have your blue power LED, which comes from an output on the Arduino, not on the power rail, to make sure that the microcontroller has booted up. Of course, you have your COM status here to make sure that comms have been established with the battery pack, and you have your status indicator here. That's your pass or fail if the battery pack has met all the charging criteria. So let's go ahead and plug the battery pack in. Excuse my butterfingers. So the fixture doesn't automatically do anything. I had it originally whenever it detected comms lines on the battery pack, it would go ahead and start, but this became very hard to work around whenever I got into programming the firmware later. Now, I'm not a firmware guru. I barely know how to program past a blank sketch, so it took me a few days to get the firmware to be right for this. I do plan to get my programming skills up to par, but for right now, they are minimal. So if there's any features that I should have put in here, it was probably because I couldn't put them in here. But let's start from how production would be. So you see here that you have a boot switch. Now, BMSs, like are found in this battery pack again, need to be booted. So you would boot your boot switch, and you see the comms indicator is blinking green. Now, this is something I wrote in. It's deglitch. So the fixture will try several times in a 5-second interval to establish solid communications with the battery pack. If it can establish solid communications, then it will proceed to its testing criteria. This is important because, especially when working with I2C, sometimes the communications have a few minor glitches. And so you need to be able to do retries, be able to redo queries and things. So I'll demonstrate here. If for some reason some bad data is sent out by the battery pack, then it will try to do redo communications. And if it can reestablish communications, then it'll go back to green and continue its test protocol. No counters will be set, no data will be erased. However, if it cannot communicate with the battery pack, then it will throw a comms error. And thus the cycle continues of plugging a new battery pack, hit the switch, it will try to communicate. If it cannot communicate with the battery pack, it either means it did not boot up or the BMS has some problems, and it will throw an error again, and thus the cycle continues. Now, you could do this with a computer, as I stated before, but this is so much easier for a technician on the floor. It gives a pass and a fail condition through these dual color LEDs and these light pops. It gives a pass fail condition, and these are the fixtures that we build a lot for our products here at Pro Technologies. The fixtures I build the most. It's funny, whenever I first started here, we did not have any smart fixtures, or very few. It was all multimeters, and this one's set to current and this one's set to voltage, and it was a lot of cumbersome things. These harnesses made to plug in with banana jacks. So I started building up these little fixtures, and they are really helpful. So if you're out there and you're responsible for providing production with test fixtures, I would strongly urge you to start developing your own. This little fixture took only, with firmware and with just a design and everything, took only about 2 or 3 days to make. And as you can see, this is a very, very nice fixture. Of course, it has a I'll show you as I turn around here, the DC jack at the back, a power switch, and then you, of course, have your harness coming out. Most people will probably comment that the harness is not removable, and that's true because I wanted to put some strain relief inside. There's a zip tie that's holding this, this harness on, but that's just a look into what I do here at Pro Technologies. This is something I do every week. I create these little fixtures and everything, and I think this one turned out quite well. It almost looks what we call store-bought, something you order from off the shelf. So I'm quite happy with this little fixture. If you want to get in contact here with us here at Pro Technologies, you're interested in us building a battery pack for you, sales@protechnologies.com. Also, this battery pack, if you're interested in buying something like this battery pack, an 8S 6P lithium iron phosphate battery pack with a BMS that yours truly designed and validated. Here I designed this BMS system that went in this battery pack. If you're interested in that, feel free to contact sales. Thank you so much for watching this video. I have to admit, I'm very happy with the way this turned out. Be sure to, again, if you're watching this on a different platform, be sure to follow me on LinkedIn for all of my updates on the fixtures I'm working on. Link will be in the description. Thank you so much for watching. Don't forget to share the video, to like, to subscribe for all sorts of new stuff that I'm doing here in the engineering lab. Thank you very much. See you in the next video.